NASA's Voyager 1 spacecraft is communicating again to ground control. It's been silent for the past 5 months. The spacecraft was launched over 46 years ago. NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again after months of spouting gibberish. After months of tinkering, NASA engineers have coaxed Voyager 1 back into sending readable information. Even after 45 years, NASA's Voyagers have continued to defy all expectations as they provide scientists with updated knowledge about the parts of space that they thought never existed. Despite having a memory capacity that is 3 million times smaller than a normal smartphone and 38,000 times slower than a 5G internet connection, these incredible probes continue to be at the forefront of technological space exploration. But recently, in a surprising twist, Voyager 1 has just stumbled upon something that was not meant to be possible. What did this probe discover? What does this mean for Earth? Join us as we reveal the impossible discovery made by Voyager 1 after 45 years in space. A fascinating discovery made by Voyager 1. While the Voyager probes were on their interstellar journey, they hit a significant milestone when they had to navigate the heliopause. It is the boundary that separates the influence of the Sun from the vast interstellar space beyond. The exact location of this boundary was a paradox with various estimates and theories. Early estimates placed it as close as Jupiter, but later calculations refined our understanding. In 1993, projections by astronomer Bill Gurney placed the heliopause between 116 and 177 astronomical units. To put this into perspective, 1 AU is about 93 million miles away. Between the Earth and the Sun, Gurney's projections turned out to be remarkably accurate when Voyager 1 reached the heliopause about 20 years later and detected the expected increase in plasma density. However, it raised a baffling question. When Voyager 1 reached the heliopause, it observed an increase in plasma density but no significant change in the direction of the ambient magnetic field. This was unexpected because if the spacecraft had traveled from a region where the magnetic field originated from the Sun to another where it came from other stars, a small change would have occurred. Voyager 2 added to the puzzle when it reached the heliopause at the same distance as its twin at 120 astronomical units from Earth, but it also could not detect any change in the magnetic field. The theoretical models predicting the behavior of the heliosphere and its interaction with the interstellar environment faced challenges due to these unexpected observations. The heliosphere was expected to fluctuate in sync with the Sun's 11-year cycle, but this did not line up with the data collected by the Voyagers. The solar wind, which flows with the Sun's cycle, was at its strongest when Voyager 2 arrived at the heliopause. The predicted position of the heliopause should have been further out than 120 astronomical units, adding another layer of complexity. However, Voyager data has provided valuable information for refining theoretical models. Scientists now believe that our Sun has moved from a hot ionized zone to a partially ionized section of our galaxy. This transition was probably caused by nearby ancient supernova stars that exploded at the end of their lives and heated the surrounding area while removing electrons from adjacent atoms. The boundary between these regions can be compared to a coast with turbulent waves and mixed magnetic fields. Although the degree of turbulence may vary, the Voyager's observations have revealed small-scale changes near the heliopause with negligible variations on larger scales. The aging explorers, Voyager 1 and Voyager 2, continue their solitary journeys through interstellar space, leaving behind the planets and moons they once called home. But what awaits these indefatigable travelers is a game of cosmic riddles. Here are some possibilities to consider. These probes are now heading in different directions, with Voyager 1 racing towards the Ophiuchus constellation while Voyager 2 is heading towards the Cetus constellation. Although it may appear that they are heading to a cosmic death in 2030, as some scientists predicted, it is still possible that they will outlive our species and last for millions of years. One day, they might encounter other star systems, bringing with them a message from a long-lost Earth, an image of an alien civilization stumbling upon these ancient artifacts of human ingenuity that carry the golden record, a time capsule of our existence. Who knows what secrets they might uncover? Since the Voyagers were sent on this mission to gather information about the cosmos, they have made multiple mind-blowing discoveries. Voyager 2, in particular, achieved several important milestones during its journey. It became the first spacecraft to pass by Uranus in 1986, and just 3 years later, it performed a flyby of Neptune. To this day, it remains the only spacecraft to have done so and has ventured down that path. As the spacecraft continues its remarkable journey, NASA has implemented a series of measures to extend its operation lifespan. Over the past 3 years, non-essential components and heaters have been turned off to conserve energy, allowing them to operate well into the next decade. With an estimated mission end date of 2030, for the scientists and engineers who have been part of this extraordinary journey since its inception, the culmination of the Voyager missions is a bittersweet moment. Their dedication and hard work have made the project advance far beyond its initial expectations. The data returned by the travelers has provided valuable information that fueled countless scientific discoveries and inspired generations of researchers and space enthusiasts. Voyager 1 and Voyager 2 were not just ordinary spacecraft but were meticulously designed to be stable platforms, with a rotation speed more than 15 times slower than the hour hand of a clock. This design minimized any visual blurring as the spacecraft captured images and data as it progressed through space. Its impressive imaging capabilities began to amaze scientists and the public even before its encounters with the outer planets. The spacecraft began transmitting images of Jupiter, although still several months away from the planet. These first images, revealing the giant swirling gas clouds and the iconic Great Red Spot, delighted audiences at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon Io that really set the stage for innovative travel observations. Io, slightly larger than Earth's moon, turned out to be the most volcanically active body in the solar system. The spacecraft's instruments detected peculiar Io signals that were confirmed by the vivid images they captured. These images revealed imposing volcanic plumes and a surface marked by the ejection of volcanic material. Pele, one of Io's most prominent volcanoes, has erupted 30 times higher than Mount Everest, covering an area almost the size of France. The Voyager spacecraft captured more than 33,000 images of Jupiter and its moons, showing the beauty of the planet and the incredible diversity of lunar landscapes in the Jovian system. Since their launch, the twin travelers have been making spectacular discoveries. One of the most surprising discoveries was the existence of Jupiter's rings. These rings, although faint, were a revelation and added to the gas giant's intrigue. Additionally, Voyager 2 revealed that Europa, one of Jupiter's 53 named moons, possessed an ice sheet believed to be more than 60 meters thick. These findings challenged previous assumptions about the nature of these distant celestial bodies and inspired further research into the potential habitability of the icy moons. When the travelers departed Jupiter, they received a gravitational assist that gave them a parting kick, propelling them towards Saturn. Without this vital boost, they would not have been able to escape the Sun's gravitational pull and venture further into space. Voyager 1 and Voyager 2 soon went their separate ways, each heading toward new frontiers. Voyager 1's path took it near Saturn's moon Titan, which is shrouded in a hazy orange atmosphere. The uniqueness of this moon piqued the interest of scientists, leading to further studies into its complex chemistry. Voyager 1 then turned north, departing from the plane of the planets, and began its journey beyond the realm of our solar system. Voyager 2, on the other hand, embarked on a series of adventures that took it to the most exterior planets of the solar system. In 1986, it made a historic flyby of Uranus, where it discovered 10 previously unknown moons, increasing the number of the planet's known moons. 3 years later, Voyager 2 arrived at Neptune, revealing the remarkable features of this distant ice giant. During its encounter with Neptune, Voyager 2 recorded wind speeds of up to 1,000 miles per hour, making it the fastest wind ever recorded on a planet in our solar system. When the spacecraft passed within 2,980 miles of Neptune's azure, methane-rich atmosphere, it provided unprecedented information on this distant world. Triton, Neptune's largest moon, was found to be